Hello, geometry students. Mr. Zacek back and better than ever, and we're in Unit 10, Lesson 3. We're going to talk about how we can find the area of a triangle using trigonometry, and this is going to allow us to find the area of a triangle when we don't know the height. Excuse me. So if you look at this green box, we know the general formula for the area of a triangle is 1/2 base times height. And the thing you always want to keep in mind about that formula is that the base is perpendicular to the height. Well, what happens in a situation where we don't have that perpendicular height? This is going to give us another option. So here I am. So the area of a triangle ABC can be expressed as 1/2. Now here we're calling this side A. So just to pull a highlighter here. This is side A because it's opposite angle A. So instead of saying BH, we're just going to represent the base with the letter A, and then H is going to represent with the height. Well, what do we know about the height? We know the height always has to be perpendicular, as we've said many times. So what have we just created? Well, a right triangle. And in a right triangle, if we were to look at angle C here, H would be the opposite and B would be the hypotenuse. So if we multiply this equation here by B, we get B times the sine of C equals H, which is our height. And so we can plug that into this picture here. We've replaced H with B sine of C, and therefore the area of the triangle is 1/2. Now let's just really get kind of clear on what each one of these letters mean. So 1/2 A is this side, B is this side, and then C, sine of C is the angle that is included. So it always has to be the included angle. So any two sides and the included angle. So another way you can think of is, so this is our new formula for the area of a triangle that we can use. Sometimes people think of this as we use when we know side, angle, side. So if you have two sides and the included angle, we can use 1/2 AB sine of C. All right, so let's do some examples with that. So Jack is planning a triangular rose garden. The lengths of two sides of the plot are 8 feet and 12 feet, and the angle between them is 87. So let's draw this picture. So he's got 8, 12. It's a garden here with this, and the angle is between them. Okay, well, this is, notice what we have. We've got kind of side, angle, side, or this would be A, B, C. So this would be side A, this would be, or vertex A, vertex B, if we were to label it that way. So it's going to be 1/2 8 times 12 times the sine of 87. Okay, so again, we're looking for the conditions of side, the included angle, and the side. We can do 1/2 AB sine of C. All right, so here it is again. Find the area of this triangle to the nearest unit. So it's going to be 1/2 18 times 12 times the sine of 55. So this would be the area of triangle CDE equals that. All right, and then at that point, all it is a matter of just entering it in to our calculator. So we would put in, let me get to a menu here of calculator. So we have 1/2, whoops, 1/2 times 12 times 18 times the sine of 55. And so that would be 88.5 square units. All right. So the area of triangle CDE would be 88.5. All right. So now here's a place where we can use this kind of as a shortcut. Find the area of the parallelogram, and we know the two sides and one of the angles. So really what this is going to be, so area of parallelogram ABCD would equal 2 times the area of triangle BCD. See, if we take this triangle and we find the area and we can double it, that gives us the area of the whole thing. So this would be 2. Now this is our side, angle, side setup. So 2 would be 1/2 16 times 12 times the sine of 125 degrees. So this would be the area of parallelogram ABCD. So 2 and 1/2 kind of cancel each other out. We could enter those if you want to, but 16 times 12 times the sine, and what was it, 125? Okay, the sine of 125 is 157.3. So 157.3. So that would be the area of parallelogram ABCD. All right. So again, we're just doubling the ones we have here. So same concept here, and number 4, and this is our last one, is that the area of parallelogram GHJK would equal 2 times the area of triangle GKJ. So again, this is side angle side, so it's our 1/2 10 times 14 times the sine of 60. And again, the 2 and the 1/2 cancel each other out, so it's 10 times 14 times the sine of 60. And we get 121.2. Okay, so 121.2. So that would be the area of parallelogram GHJK. All right, so just another tool in the toolbox, and quick one, but let's move along, keep things rolling, and I'll see you back here soon.